Hi roboticist and welcome back in this new ROS2 tutorial. Well, if you ever tried working with industrial robot in simulation, you know how overwhelming it can be to dive into a complex ROS package, especially one you didn't write yourself. And this is the exact example of a repository of Universal Robots. So now we are going to break that barrier and you will learn how to spawn a Universal Robot 5 industrial robot inside Gazebo, complete with its own joints controllers using the official Universal Robots GitHub repository. But more important, you learn how to take that existing package, understand its structure, and build your own custom ROS2 package on top of it to fit your specific application needs, like for example, position of the robot in your world, the gripper, the controllers, and so on and so forth that we're gonna see. So this is a super valuable skill if you are planning to simulate industrial robotic application or you want to start developing for the real thing. So by the end of this tutorial, you'll not only have a Universal Robot 5 up and running in a simulation in some kind of framework in your ROS2 workspace, but you'll also have a solid understanding on how to adapt and repurpose someone else's ROS2 code. And this is going to be a key ability in the world of robotics software development. And now let's get started. We are using ROS2 Humble distribution, and in particular, we having Ubuntu 22.04. So open a new terminal, and I'm expecting that you have already a ROS2 Humble installed on your machine. I have done a video, and I'm gonna provide the link in the top right corner. Okay, so now let's create a workspace. You should already know how to create a workspace, and we're gonna call it, let's say, Universal Robots YouTube workspace. Now what we need to do is to clone inside the source folder of our workspace some packages belonging to the Universal Robot GitHub official repository. And in particular, we will need to clone two repository, the ROS2 description that describes the Universal Robot 5 and basically the model in a URDF chakra file. This is the one, so let's do it. Make sure to get the humble branch, so copy and then run inside the src folder and run git clone. There we go. The second package that we need to do is the package for Gazebo simulation. So if we run inside the list of the repository, we should get, let's say, this is not the one because this is for the initial simulation, but we need the Gazebo simulation one. Okay, so Universal Robots ROS2 Gazebo simulation. Okay, so this is already in the humble. So let's copy this and clone inside our workspace. You can follow this instruction. Let's use ROS.dep to install all the dependencies that this package has. and then build the package. Okay, there we go. Up to here, nothing special. We just clone the two key repository in our workspace. So before to go faster, make sure to install the following package in your machine. So the most important, and in particular, we need to install the ROS2 control, the ROS2 controllers, but I'm gonna provide the list in the description down below. Okay, before to run the simulation of the package already present, let's have a look in it very fast. And there we go. So here we have two packages. The one that is ROS2 description. And you can see that there are all the description of the model Universal Robots. The key important thing is the structure is divided in this particular manner. So what you're gonna have is the Universal Robots UR5 shadow file that here is I would say the master file, okay, from which we are gonna call the children I would say chakra file. Okay, so here contains all the description and the links for the key components of our universal robot. So this is the master, and in particular, when you want to make a universal robot 5 custom based on your specific needs, you will need to copy only this file here. Okay, and then you're gonna set up the position and the orientation of your robot with respect of the world. Okay, so we are gonna have that all these parameter will be used in this universal robot macro. Okay, so basically the structure here is that you're gonna define the parameters that you will use in the macro universal robots. Okay, and where this macro is contained, well, is contained in this file, in this universal robot underscore macro, that is this one. Okay, so then if you look at here, you're gonna see some files that are general regardless the type of the model of a universal robot. It can be 3, 5, 10, 5e, etc. Okay, and here you're gonna have you're gonna define all the parameter for the macro, the parameter that you have set up it here. Okay, and then basically you're gonna include a universal robot ROS2 control. Okay, in this file it contains the macro universal robot ROS2 control. And guess what? This file, which is here, will contain the most important thing, the ROS2 control tag. Okay, and in this ROS2 control tag, you're gonna load the in the hardware tag the Gazebo plugin that you will need. And in particular, here we're gonna have that if simulation Gazebo is true, okay, then you're gonna use this plugin. If you're gonna use sim ignition, is gonna be this plugin. If you're not gonna use the controller and Gazebo and ignition either, or for example only Rviz, you're gonna use these Moco components. And then if all the others are false, then you're gonna use this type of plugin, which is gonna be Universal Robot Driver. And these are all the parameters that are needed for deploying your robot in the real world. Okay, and then you're gonna see set up all the state interface, command interface for each joint. We are gonna do a specific tutorial for the ROS2 control. Okay, but this is the key things. And here in particular, you're gonna set up as default that this simulation gazebo is false, and also here false, and what probably you will need to do is to set up the gazebo simulation here to true. Okay, but we are not going to do that because I will suggest you to do not touch a package of someone else, because if something happens, it's really difficult to troubleshoot this. Okay, so the purpose of this video is to copy the essential part of the package that someone else has written to make it own, and modify only the things that we need in order to fit our specific needs. Okay, so we have seen this Universal Robots ROS2 description that, as I told you, it's contain the meshes, launch file only for seeing the Universal Robot we are going to see in a while. Okay, but this is only the model. Okay, but and it contains also the ROS2 control tag. Another important thing is this package that basically contains, the name is this one, Universal Robot Simulation Gazebo, that basically contains the launch file to simulate our robots in Gazebo and interface with Move It. Okay, and so what we're gonna do is to use this in our package and to spawn our robots in Gazebo. Okay, that should be it for this introduction. So for example, let's try to spawn our robots in Gazebo by launching this launch file. Okay, so I also this movie. Let's do step by step. So let's, for example, we have source, etc. So we can launch ROS2, launch, then the name of the package that is going to be Universal Robot Simulation in Gazebo, and then we're going to spawn Universal Robots Sim Control. Let's see what's happened. Okay, so you can see that the robot is spawned in Gazebo correctly. You're gonna have Rviz here. Okay, awesome. Okay, so it's quite useless because we don't have an interface like move it to control, but what we can do is, for example, to check the control that we have. Okay, so we are gonna have a joint state broadcaster and a joint trajectory controller. Okay, so basically the joint are publishing this type of message. Okay, so let's send a command to the joints. Okay, so there we go. So this is the type of the message, which is very complex one. So I'm sending the robot to this position for this joint 1, etc., up to RIS3 joints. Let's see if it's moving, and there we go, it's moving properly. And in Rviz, okay, this is like this because it's trying to go down a little bit, but there's the wall here, and that is in contrast. Okay, it works. So, but let's test it. Let's test. It's better to test the move it interface. Okay, there we go. Let's bring our end effector here. Okay. So awesome. We can see that this package works properly, and this is a good check to see if you have all your framework, I would say, in your inside your workspace that run properly. Okay, this is good. But now this is the key part, the heart of this tutorial is to create another package and make this simulation that fits our specific needs. And in particular, we want to spawn our robot in another position and in our own package. So to do that, let's clear this and let's create another package. So ROS2 package create. Let's call it Universal Robots, let's say YouTube simulation sim, okay, for abbreviation. Okay, so I'm gonna push this package in a GitHub repository. I'm gonna provide the link in the description down below. Okay. Okay, so in this package, what we wanted to do is a description, a file, so a URDF folder, and we wanted to run a simulation in Gazebo of our robot inside this package that is spawned in another position. Okay. And then we will use this to interact with move it, and we are gonna put a gripper and so on and so forth. Something that we will see in some other videos that I will make in the upcoming weeks. So let's put some folder that are gonna be useful for giving a structure in our custom package. Okay, so let's update the CMake list file in order to include this folder. Okay, so the first things that we need to do is to create our Universal Robot 5 model, okay? And we are gonna call it Universal Robot 5. We will set up a camera also, okay? So this is a proof that we are gonna use, we are gonna have a custom package on it, okay? So this is gonna be urdf.chakro, okay? What we're gonna do is to take the URDF from the official package and copy this one that we have said that is the master. Okay, and there we go. Okay, so now an important thing that you need to bear in mind is that here the name has you need to provide a name. Otherwise, in Gazebo it will work, but you will not able to create a move it package because because move it doesn't recognize the name argument name. So if you put this on top of it, okay, like this, for example, okay, is gonna be a problem of a chakra, but move it, it will recognize because it associate name to here, okay? And if you're gonna keep it like this, move it is not recognizing. So what you can do is to the first modification of the package of the file that you need to provide is this one. Okay, you provide a name, that's all, okay? Then, since that we are going to modify a little bit, I would suggest you to create another file that we can call Universal Robot 5 macro that can be a copy of this one. Okay, so let's do the second modification. Okay, so then we need to create a file and we can call it Universal Robot 5 macro. That it will be the copy of this macro here. Okay, there we go. So if we go down here, we will need to add also this one because we are going to control it. Okay, so since that generate ROS2 control tag is gonna be true, let me say yes. Okay, it's meaning that we are going to include this file and we are going to use the macro Universal Robot ROS2 control. So we need to create this one. Okay, so let's create a new one and let's call it Universal Robot 5 dot ROS2 control dot chakra. So first of all, let's update this line here. There we go. Let's take this and copy this one. Okay, so this is the first structure of our custom Universal Robot 5, okay? So we need to modify a little bit here, right? So first of all, we need to set up it to Universal Robot 5, okay? Because inside our macro, we are gonna use, you will see that the official package is set up with the include, you're gonna have a lot of universal robot type that is belonging to the type that you're going to set up. Okay, these are all the model. Okay, so since that we are going to use a universal robot 5, we can use this. So we can keep all this file belonging to the universal description package. So we need to modify this in order to make it use inside embedded in our custom package that we have created with the name Universal YouTube Simulation. Okay, so then what we're gonna have here is in the config we are gonna set up initial position. Okay, so what we can do inside our config file, config folder, sorry, we are gonna set up the initial position as well. .yaml. Okay. Okay, so basically is gonna be the position where the robot stands. Okay, and so we're gonna use a config initial position. We just copy here and we can put it here. Okay, so this is the position where the robot is in the up position. Okay, then here an important thing. Here we're gonna set up simulation gazebo. This is gonna be set up. This is very important. So this is the part that we need to modify. First of all, the first thing that we need to modify is telling to the system that the sim gazebo is true, because we are going to use simulation gazebo, and it will transmit in all the children's chakra all the simulation gazebo to true. And in particular, if we're going to set up it to true, okay, then all the other let's say a chakra file that are the children, like this one, will take into consideration that the simulation gazebo parameter is going to be true. So regardless the fact that this is here to false, this semicolon and equals, it's meaning that if nothing's happened, this is going to be false, okay, if you're not defining in the father file. Okay, since that here we have set up it to true, this will be transferred to all the children's chakra, okay, and this is very important. So again here, since that we're gonna set up it to true, then here we're gonna be true, and then this is gonna transfer to Universal Robots ROS2 control tag. Here is going to be true, okay, and since that the Sims Gazebo is true, then we're going to use this plugin. Okay, very important, and this is necessary in order to simulate the controllers inside Gazebo. Okay, so this is the a key point here. Okay, another key point here is the simulation controller here. Its default is nothing here, so meaning that we need to set up. And in particular, this is the one because since that in the libgazebo ROS2 control libraries, okay, we're gonna use this parameter, okay, but since that here nothing is set up, simulation controllers here, nothing set up is meaning that it won't work in Gazebo inside our custom package. Okay, so again here we are going to use Universal Robots tag. Then I have already told you in the previous video that we need to set up the Gazebo tag, in particular the plugin and the library that Gazebo uses to spawn the controllers, and the parameters is going to be the YOM file for our controllers. Okay, so here we will need to set up it here. So where this file should be in our package and how it's done. Okay, so this config usually is going to be inside the Gazebo simulation package. Okay, so if we go inside the Universal Robot Gazebo simulation, in particular this one, config, there we go. So this is the YAM file that we are looking for. Okay, so just copy it. Okay, and then let's create here inside the config folder of our package Universal Robot 5 controllers dot YAML. There we go. And in particular, we will talk to the launch file that we're going to use this one, but we will see in a while. Okay, so here we need to say, okay, there we go. So we have set up our controllers. And another important thing is here, the position of the robot in the world. As default is 0, but let's say that we want to put our robot in upper position of 0.8 meter in the Z coordinate frame with respect of the world frame. Okay, so basically that's it. So we have modified our universal no. So now what we need to do, we have So now we have modified everything for our universal robot. Okay, so we are calling a macro. We are telling most important that the simulation gazebo is true. This we have set up the simulation controller and we set up the position of the base link with respect of the frame word. Okay, and you will see that all the macro will be updated accordingly, and in particular we are going to use the Gazebo ROS2 again, we have modified this name here to Universal Robot 5. We have created our Universal Robot macro and we have put it inside our URDF folder inside our package. We have modified this, specifying that we are using, we want a Universal Robot 5. Then we have set up Simulation Gazebo to true. We have set up the simulation controllers, okay, and we have taken from the package Universal Simulation Gazebo. We have set up the initial position. Again, here we are gonna use the one that we have set up in our package Universal 5 Universal YouTube sim and basically then basically that's it. And we have modified the position of the robot in the real world, and we are putting the base link up to 0.8 meters. Okay, then here for the fact we are not modified basically nothing, and for the fact that we are set up simulation gazebo to true, then inside the universal the ROS2 tag that is belonging to this macro that is here in this file, we are going to use the plugin Gazebo ROS2 control Gazebo system. Okay, so that's it for the moment. And before to spawn our robot, let's put a camera here, and we're gonna use a depth camera. So there we go. We have included a camera chakra file. Honestly, I have copied from another package. I thought that we have seen how to do that. So basically, we are set up the camera link. The most important thing that you need to know is that I put the meshes for this camera, that camera inside the meshes folder. It's gonna be a kinetic one, and basically I'm gonna set up the camera optical link. This is the position. This is the position and the orientation of the geometric shape of the camera with respect of the base link of the robots, and this is the camera optical link which is referred to the as a gazebo entity, okay, for simulating data for point cloud, for example, using these libraries, libgazebo ROS camera. But I'm gonna provide a video more detailed for the camera handling in ROS2. Okay, another important thing that I made is to update the file, the father file, camera chakra file, and also here I had to set up the Gazebo ROS tag, and in particular I had to say to the ROS2 package where physically is stored the model, the geometrical model of our camera. If you don't provide this line of code here inside the package, a file of your custom package, package, well, Gazebo won't be able to rendering the camera. Okay, it's gonna function in Gazebo, but is not rendering it. Okay, so before to spawn in Gazebo, what we can do is to visualize in Rviz. Okay, and what we can do is to go to the launch file and let's create a view um, Universal Robot 5 with a camera dot launch dot py. Okay, and we are gonna use we are gonna copy this from this one. So this is the launch file that we will use. Okay, so let's update this. So basically, this is the name of the package that is the description package, and basically this is the Universal Robots YouTube sim. Of course, you need to update to the name of your package. This is the description file, and as I told you, is the father, okay, of all the model of your robot with a camera, with a gripper, whatever it's gonna be. Universal Robot 5, then camera dot urdf dot chakra, which is this one. Okay, we don't have a prefix. Okay, so for the moment we are not going to have this because we will save the Rviz configuration later, and then all the nodes. Let's set up the value as default of Universal Robot 5. Okay, it should be it. So now let's save, build the package. Okay, then source the environment. You need to do this every time that you create some new folder and file. Okay, now you're ready for checking in Rviz. Okay, let's troubleshoot the problem. There we go, there's a typo error. It's gonna be initial position. Okay. Okay, now should work. So let's check this. So this was the so let's check here. So here we wanted to set up to the word frame. Let's add the robot model and set up as a topic robot description. Okay, there we go. So here you can see that we have our Universal Robot 5, okay, position in 0.8 in height with respect of the frame word, and then we have our camera. Okay, and thanks to the joint state publisher GUI, we can take some confidence with the position of the joint of our Universal Robot 5 robot that was exactly taken from the official repository. Okay, so let's save the configuration. So center, there we go. So this is gonna be the configuration that we want to save. Let's copy here, save. There we go. Let's close it and let's open again. So let's set up. Let's set up it here. Universal Robot 5 camera dot Rviz. There we go. Okay, that should be it. There we go. So it's working. This was the old one. Okay. Okay. So now what we can do here is to spawn our robot in Gazebo. And to do that, we just simply to create a launch file that we can call it spawn what a Universal Robot 5 a camera dot launch dot py. Okay, so there we go. So what we can do is that we can copy the launch file Universal Robot Simulation Control here and paste it inside our custom package and modify it. So how to modify, we're gonna see in a while. Okay, there we go. So what we have done is to copy the file that was inside the Universal Robot Simulation Gazebo, Universal Sim Control, and I have adapted it. Okay, so when you have time, feel free to check the difference. But I wanted to highlight the difference. So here I have updated the name of the Rviz configuration file that we have just saved. And here basically nothing changed. Of course, you're gonna have robot state publisher, the controller manager node, and in particular the joint state broadcaster that is contained in the file Universal Robots controllers. Here we are gonna see in a while where it's called. Then basically all the node that we need to start. Then we set up the default value Universal Robot 5. Then I have changed the name of the runtime configuration package that is a Universal Robot YouTube simulation. So these files contains the information of the description of our model and also the configuration for the configuration of the controllers of our robots. Okay. And then in particular the controller file is this one that we have just seen, okay, with all the controllers that we can spawn. Okay, then we set up the initial positions, Here we need to change the name of the description package, which is this one, okay, YouTube simulation, okay, and then the file, the father file to which it gets everything, okay, the Universal Robots 5 camera URDF chakra, okay. So this is the name of the controller that we are going to spawn, a joint trajectory controller, okay, which is the initial joint controller variable that we have set up in the previous file of this launch file. Okay, everything should be good. So let's test it. So there we go. There we go. The robot stands in the right position. And let's see here in Gazebo. There we go. There we go. Very nice. So we can see that our robot is spawning in the position 0.8 with the Z. And then the fact that the robot stands, it's meaning that the controller are spawned correctly. Okay, so let's test the controllers. So by the way, so you can see here that the joint trajectory controller and joint state broadcaster are good. So let's, for example, let's check the node that we are available. So the controller manager is okay. So then what we can do, first of all, check the controller. So ROS2 control, and then list of controllers. Okay, so we have joint trajectory controller, perfect. So what we can do is to send a trajectory message to all these joint. Let's try to see if it's moving, and there we go. So it's meaning that the controllers are working fine. Okay, let's check if the camera works properly. So for example, let's add a point to cloud, and let's set up as a topic camera points. Okay, there we go. So this is the data of type points that we will use in a points cloud library tutorial in the upcoming weeks. Okay, perfect. That's all for today. I hope that you enjoyed this video. So basically, as a wrap up, we have spawned an industrial robot, in particular Universal Robot 5, in Gazebo with a tailored package that meets our need. So we wanted to spawn a camera in a specific position, and we wanted to spawn a robot in a specific position with respect of our frame world. And I have gave you some kind of formal mantis and the tools in order to provide your own custom package and use an official repository from GitHub. And in particular, we have seen all the key feature that your package has to have have in order to control your robots in your own setup environment and industrial environments. Okay, this is the top of the iceberg because if you wanted to have a deep dive and master your career being a robotic software engineer, you can check up the link in the description for the masterclass of ROS1 and ROS2. So there we go. You can have a look at here. We're going to use ROS1, ROS2, move it one, move two. We are going to simulate in Gazebo, and we're going to interface with some camera using some computer vision stuff like OpenCV and Point Cloud Library. The course is still under construction, but you can see here all the lecture. And basically the point here is to all the engineers or technicians that want to uh, understand how to develop and program an industrial robot for his own project or for the company and he's working with. And basically at the end of this master, the purpose is to give you all the tool to deploy a robotic solution that involves an automatic task, and to give you the proficiency to go to your boss and say, hey, okay, I can do that, I can handle this automatic task with the robot from the beginning to the deployment. But okay, the course is under construction, so you can benefit a 75% of discount. And I'm gonna put everything in the link in the description down below. Again, I hope that you enjoyed this video. Feel free to reach me out if you have any doubt. And as always, keep learning robotics with ROS.